The figure shows the graph of a trigonometric function f. Which of the following could be an expression for f of x? So they say we could use either sine or cosine. So that's issue number one. So let's do this. Let's set up where we could be. Okay, I'm going to write out basically what I consider the general form for a sinusoidal function. So a times trig, which could be sine or cosine, times b quantity theta minus c, close it, plus d. Now what we're dealing with in all of these is a is your amplitude. Now, before you say amplitude, if you're like, well, from the bottom to the top, it looks like it's 6, correct, but you want half of the total height. Okay, so our amplitude in this case, which goes from -4 to +2, our total height is 6, which means our A is 3. So we start out by saying that it's going to be 3 times blah, 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 blah. And so far, all of these contain 3, so that didn't help. I'm not going to worry about the trig function, not yet, okay, because I have either sine or cosine, and the last thing I want to do is try to pick one and pick the wrong one. All right, now let's see what b is. Always the trickiest part. B is going to always equal, for something that's sinusoidal like this and dealing with radians, B is always going to be 2 pi divided by your period. Okay, now if I just pick like the tippy top here, boop, to the tippy top here, boop, that is a change of 3 pi over 2 minus 1 pi over 2, which is pi or 2 pi over 2, or pi. So the period is pi. So B is going to be 2 pi over pi, which means B is 2. Cross you out. So looking at these, which one of these has 2 for B? All of them. So that didn't help. Now, I'm not going to do C yet. C has to do with the left or right phase shift. All right. Since I'm not choosing my sine or cosine yet, I don't know my phase shift yet. Okay, so I'm not going to worry about that yet. What I am going to worry about is D. D represents the horizontal phase shift. And in this case, if we're supposed to have everything exactly from -3 to +3, and we don't, and it looks like it's just shifted down 1, where maybe this could be the beginning or something like that, it looks like what we're doing is we're moving everything down 1. So my D is going to be -1. None of you. So far, nothing is helping me. Nothing is helping me at all. So what I have to do is now I have to choose, do I want a sine or a cosine? And let's choose sine, because why not? Okay, let's choose sine because why not? If it was a sine, this is where I would start. Okay, so if it was a sine, I would have sine blah, 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 theta, and then I figured that if it's supposed to start here, that is me moving my graph to the right 1, 2 blocks. So if 4 blocks is half a pi, then 2 blocks is a quarter of a pi, like so. So x minus a quarter of a pi. So one of these rules, one of these graphs that I could have is 3 sine, what is that? 2 theta minus pi. So do I have a sine theta minus pi over 4, x minus pi over 4? Yeah, I do. So this guy will work. So I kind of did things the long way. What may not be the worst idea here is if you look at these and notice you're exactly the same, you're exactly the same, you're exactly the same, and the only things that are different are the fact that I have sines, cosines, and horizontal shifts, then it may not be the worst idea to just start from there and see if what you're doing is okay. So if you're like, oh, well, man, this looks like a cosine, but it's a negative cosine, so I don't like that. So, is it a cosine where I move over pi over 2? I don't move over pi over 2 for my cosine, so it can't be any of my cosines. I didn't want to do that. It can't be any of my cosines, and the only sign that works is this one because I'm not shifting over pi over 8. That would have me start here. So very strange problem. This is no calculator, so it's not like you could just plug it into your calculator and see what works out. This is you really knowing how to do phase shifts left to right, and it's definitely not pleasant at all.